One of the reasons that I like to emphasize on the theory is that so that you could understand what is going on behind the scenes and on the background, so that you would be able to sometimes predict the behavior of something. For example, in here, what I want you to predict is that what would happen if we remove these 3 lines of code. As we explained in the previous lectures, we invoke 2 system calls in here. One of them is the write system call, which would cause the printing of the hello world out on the screen, and the other one is to exit. Now let's say what would happen if we remove these 3 lines of code. Well, actually, let me just show it to you in here. So we have 10 bytes, 15, 17, 20, 25, and then 27 bytes until we reach the B8 in here. So we have 16 bytes at the first row, and this would be 24 bytes, 25, 26, 27, and we would have the B05, B8, the B8 and C3C. So we have B8 and 3C, and then we have the rest, which is zeros, 3 byte zeros, BF00, and until we reach the end, which is 0F05. So what would happen if we remove these lines of code in here? Well, if you notice, it's just a series of bytes. The CPU is not smart. It doesn't recognize some of them being the text section or the code, some being data. It just fetches the bytes from the memory and then giving them to the decode unit and just executing them just sequentially. So if you look, after this 05, we get to 00, 68, 65, 6C. This is the way that they are loaded into the memory. So nothing would happen. The CPU would just go on. So it looks at its ISR or instruction set architecture and just decode them as instruction. And well, because they are wrong instructions or they may not exist, it's possible that it jumps to an address or it wants to go to an address while that address, for example, is not accessible or something like that, and the instruction wouldn't make any sense. The byte wouldn't be equivalent to any instruction, and eventually it would give us like a segmentation fault or an error like that. So this is what we could predict using the information that we have learned before. But the important thing in here that I want you to notice is that the CPU doesn't see anything other than bytes and bits, which it gets them, gives them to the decode unit, and just executes them. So I want to go to the hello world.nasm in here, Control X, just type ls. So we have hello world.nasm in here. I want to say the hello world.nasm, copy it into another file, let's say hello world2.nasm, and then go to the hello world2.nasm and remove these 3 lines. Go back in here, say nasm FELF64 hello world2.nasm -o to assemble it, create the object file, use the linker, create the binary, hit enter, and now execute the hello world2. If we hit enter, you see that it first gets the hello world printed on the screen, and then you would have segmentation fault. As I explained to you, it just gets every one of these bytes, execute them until it could print the hello world, then it reaches other bytes, wants to decode them, but they are not what we wanted it to do. So eventually it would reach a point which it wants to retrieve some information or goes to another memory address, and then it would just crash in here and gives us the error of segmentation fault.